All right, so this is the review for Algebra 3, chapters 1 and 2 to prepare for your semester exam. So number 1 and these first 4 problems actually were solving various equations. So this number 1 is an example of a rational equation. So we're going to solve this by finding out what the lowest common denominator is and multiply by that on both sides. We can't know for sure what the lowest common denominator is until we do all factoring. So everything is factored on the left side, but this right denominator can be factored as x minus 2 times x plus 1. And now we can see for sure that our LCD is going to be x minus 2 times x plus 1. So I'm just showing that I'm going to multiply by that on both sides of the equation. We're doing a process called clearing the denominators. We are removing the denominators so we don't have to work with fractions in our equation. So when I divide x minus 2 into this lowest common denominator, it leaves me with x plus 1 to multiply times x. So that would be x squared plus x. And the denominator is gone. It canceled when I divided into the LCD. All right, I'm going to do the same thing with x plus 1. I'm going to divide, and it cancels out with this x plus 1 in the LCD. So that leaves x minus 2 to multiply times 2. And that's 2x minus 4. And on the right side, when I divide anything into itself, it just becomes 1. So I'm going to multiply 1 times 7x plus 1. And now it looks like I'm going to have a quadratic equation to solve, so I need to make it equal to 0. I'll go ahead and combine like terms on the left. And then I'm going to make it equal to 0 by subtracting 7x. And subtracting 1. And now you can choose, since it's not specified, you can choose any of your favorite methods for factoring or for solving. Factoring is possible because you can use the factors x minus 5 times x plus 1. And so we get 2 possible solutions, but you want to be careful because if a solution like -1 creates 0 in any denominator, we can't use it because we can't divide by 0. So even though we got -1 as a possible solution, I'm going to have to throw it out. It's called extraneous. It cannot be used in this particular problem. So the only good solution of the 2 would be x equals 5. All right, number 2 is it's called a quartic trinomial, but it factors just like we do quadratics. So just think if this were x to the second, we would have x times x here, but since it's x to the 4th, we just make them both x squared. And now we're going to come up with the factors of -4 that add up to -3, and that would be -4 and +1. So this factors just to put it in more familiar terms, you would factor it just like you did this back in Algebra 2. It's just that the x's become squared when it's x to the 4th. And now take each one of these and make them equal to 0 and solve for x. So remember, we're looking for 4 solutions. So there's 2 of my solutions. And then the other 2 will be plus minus I. The square root of -1 is I. Okay, any questions on those 2? That makes sense? So be prepared for problems like this on your exam. This is a radical equation, so we have to isolate the radical first. So that means I'm going to subtract 2 from both sides first. And then I'm going to get rid of the radical by raising, since it's a square root, I'm going to raise both sides to the second power. That gives me 2x minus 5 equals 4. 2x equals 9. X equals 9 halves. And it's a good idea to check these and make sure that it actually makes the problem work. So 2 times 9 halves minus 5, we'll do the square root of that, plus 2. We want to know if that equals 4. Just going back to the original problem. 2 times 9 halves is 9. 9 minus 5 is 4. And the square root of 4 is 2. So we verified that 9 halves actually makes the original problem work, so it's a good solution. Okay, number 4 is an absolute value equation. And we want to, just like we isolated the radical first, we want to isolate the absolute value first. So that means subtract 7 from both sides. So just remember, absolute value equations, it all goes back to a simple equation like this. In this little equation that I have, there's actually 2 numbers that would make this work, positive 8 and negative 8. So for that reason, when you're solving an absolute value equation, you have to consider both a positive result, and then you also have to consider that it could be a negative result. So you're going to set up 2 different equations. The part in the absolute value never changes. It's the number that we let it equal. You'll have one positive and one negative. And now let's solve for both of the x's. So on one hand, we got x equals 3. And on the other hand, we got x equals 0. Let's check both of them out. So if I let x be 3, that's 6 minus 3. The absolute value of 3 is 3 plus 7. That equals 10. That works. If I let x be 0, I get the absolute value of negative 3, which is also 3 plus 7. That equals 10. So they both are good, but you definitely want to check them out. It could be that one of them works and the other one doesn't. Okay, so for number 5, I'm going to square this binomial. So you could write this down twice and use FOIL, but I'm going to do the 3-step mental math. Square the first term, that would be x squared. Multiply x times 1 and then double that. That would be 2x. And then square the last term. Just going to bring everything else down. So now I'm going to go ahead and do the distributive property with both of these numbers. So 2 times all 3 of these. And then negative 5 times both of those. And we'll combine like terms on the left. 4x minus 5x is negative 1x. And then 2 minus 5 is negative 3. And then it's a quadratic equation, so we got to make it equal to 0. And then in this case, you might want to use the box method. So I'll go ahead and review the box method with you just in case. You might want to use it on your exam. So we put the first and the last terms across from each other. We multiply those together. And then I'm going to try to find the factors of negative 12x squared that add up to this middle term. So that would be negative 4x times positive 3x. And then fill in the other empty spaces with those 2 terms, and it doesn't matter where they go. So the GCF of the top row would be 2x, and the GCF of the bottom row would be 3. This first column, the GCF would be x, and then this would be negative 2. So there's the factoring. And then I'm going to let the factoring help me solve. So just, if you don't actually write it down, just think of each of these factors equaling 0 as 2 different equations, and you're going to solve each one. So x equals negative 3 halves will be one of my solutions. And then x equals 2 will be the other. All right, for number 6, let's take a look at this problem. First of all, I'm going to change this a little bit. It looks a little confusing, at least it does to me. This means the square root of 2 times x. At first glance, I thought the x was underneath the radical, which really changes the way this problem is approached. So if I give you a problem like this on your exam, it should be written like this: x times the square root of 2. Okay, and now we can set this up to prepare to use the quadratic formula. It's just a quadratic equation. And the opposite of b. Now I know this is turned around, but b is the square root of 2, a is 1/2, and c is -1. So the opposite of b, which would be positive square root of 2, plus minus the square root of b squared, so that would be 2, minus 4 times 1/2, which is 2, minus 4 times 1/2, which is 2, times -1, which makes -2, all over 2 times a, 2 times 1/2, which is 1. All right, so that's going to be the square root of 2 plus minus, this is going to be the square root of 4, which is 2, and we don't really need the denominator 1. So that should be your answer then for number 6, solving that quadratic equation. Right, number 7, another quadratic equation. I would always check to see if factoring is possible first. Doesn't look like it is, because we would need the factors of 20x squared. That would add up to -4. And don't see that those exist. So let's just go ahead and get into the quadratic formula. So the opposite of b plus minus the square root of b squared, minus 4 times 4, which is 16, times 5, which is 80, all over 2 times 4, which is 8. And this would be the square root of -64 over 8. And the square root of -64 is 8i over 8. And so you could reduce this by dividing by 4 into all of these numbers. 4 divided into 4 is 1. And this is 2i. And this is 2. And you could break that up as well if you wrote it as 1/2 plus minus I. That's also acceptable. Just dividing 2 into both parts, both of these parts of the numerator. All right, this one does factor. It's quartic, but we're going to factor it as 2 quadratic binomials. The factors of -4 that add up to +3 would be +4 and -1. So I've got the factoring, and now I'm just going to set each of these factors equal to 0 and solve for x. So x squared is -4, so x is plus minus 2i. X squared is equal to 1, so x is plus minus 1. And there's your answers for number 8. Numbers 9 and 10 represent combined inequalities, and if you have an absolute value less than, that means you're going to be doing an and compound inequality. Absolute value greater than represents an or compound inequality. You just want to make sure you isolate the absolute value first. I went ahead and called this one or because I know that's what it's going to be, but if, for example, you had to divide by -2, for example, to get the absolute value by itself, then dividing by negative on both sides would cause this to switch. And so you can't really make that determination until you have isolated the absolute value. Okay, so to show and means the word between. That's the key word that we use to associate with and. So I'm going to write a combined and inequality statement, and it's going to look like this. I just put -8 and +8 on either side, on either end, and let the absolute value part, the expression inside the absolute value, go between. And now I'm going to solve for x. So I subtracted 4 from all three parts, and now I'm going to divide by 3. And I'm going to show this using interval notation. So the interval that contains our solution will be the numbers between -4 and +4/3, or 1 1/3. I use parentheses because it doesn't say or equal to. And then the graph of this, you can just use what you're typically used to. It's fine. So we put -4, we put 4/3. We show that neither of those numbers are included in the solution, but all the numbers in between them would be. All right, so to set up the or, first of all, of course, we have to isolate the absolute value. And now I'm going to set up basically a combined inequality using the word or. Two different inequalities. Notice when you set up this second one, you switch the inequality and then you change the number to negative. It's like you had to multiply 7 by -1, and that would force you to change the direction of the inequality. All right, so x is greater than or equal to 6. Or we could have x is less than or equal to -1. So using interval notation, we could, I'm just going to go with this one first. So all the numbers to the left of -1 would look like this. And in this case, we're including -1. And then we're going to combine that with all the numbers bigger than 6, including 6. And then the graph would look like this. So we have -1, we have +6. So we have including -1 going to the left, and then including 6 going to the right. Okay, chapter 2, we did a lot of work with linear equations like number 11, the equation of the line containing these 2 points. So we first have to find the slope of this line. y2 minus y1 over x2 minus x1. So this would be -6 over 3, which is -2, is the slope. And then just choose one of these to plug in for x and y. I'll just use this first point, y equals mx, and then solve for b. So b is 2. So the answer to this one would be y equals -2x plus 2. All right, find the equation of the line perpendicular to y equals 2x plus 1 and containing 3 5. So the slope of y equals 2x plus 1 is 2. So for the line perpendicular to it, the slope would be -1/2. And so now I'm going to write the equation using this point. So y equals mx and solve for b. -3/2. So this is 10/2. That's 5. So I'm going to add 3/2 to both sides. So b is 13/2. So my equation is y equals -1/2 x plus 13/2. And now I'm supposed to express your answer in slope-intercept form and graph the line. Okay, so the graph of this line is 6.5 on the y-axis. and a slope of negative 1/2, down 1 right 2, or up 1 left 2. And I'll try to draw a straight line through those. So just so you can see, you can check it out, let's do y equals 2x plus 1 and see if they are perpendicular. So y-intercept 1, slope of 2, up 2, right 1, up 2, right 1. And looks like, although my lines are not very straight, you can see that they do form a right angle, meaning that they are perpendicular. All right, 13, 14, and 15, let's list the intercepts and test for symmetry. So I'll start with x-intercepts. For x-intercepts, I'm going to let y be replaced with 0 and solve. All right, and you can this is the difference between two cubes, and it factors like this. So I'm going to have an x-intercept of 3. If we did solve this, it's going to come out to be imaginary numbers. I can prove that to you. Let's just do completing this. We'll just go ahead and do the quadratic formula. Opposite of b plus minus b squared minus 4 times 1 times 27. 4 times 27 is 108. So you can see we're going to have a negative number under the radical, which means that these two solutions are imaginary. We can't plot imaginary numbers on the x-axis, so our x-intercept is going to be just the number x equals 3. For y-intercept, we let x be 0 and solve, so that's easy. Our y-intercept is going to be negative 27. All right, and now let's test for symmetry. So for x-axis symmetry, we will change color. We'll replace y with negative y, and if we get the same result, it's the same function. That proves that we have x-axis symmetry. But if we solve this for y, of course, we're not going to have the same. We're not going to have the same function. So there is no x-axis. So this is my x-axis proof. So y-axis, we replace x with negative x. And see if we end up with the same result. So that would be negative x cubed minus 27. That's not the same as the original, so no y-axis symmetry. So origin symmetry means we replace both. Y becomes negative y and x becomes negative x. So negative y equals negative x minus 27. So when we do multiply on both sides, then we get positive y equals x plus 27. So we didn't get the same original function when we did all three of these tests. So the bottom line is number 13 has no symmetry with respect to any of those. All right, so for number 14, if we want to find, we'll start with x-intercepts again. So let y be 0 and solve for x. So 9x squared equals 36. X squared equals 36 ninths. X equals plus minus the square root of both of these. Well, we could just, let me just go ahead and call that 4. Sorry about that. 36 ninths is 4. So x is plus minus 2. So those are the x-intercepts. Y-intercepts, let's let x be 0 and solve for y. Y squared equals 9, so y is plus minus 3. So we have two x-intercepts, we have two y-intercepts, and now we'll do our symmetry test. So let's do x-axis first. So we're going to let y become negative y. And when we do, we get the original equation back because negative y squared becomes positive. So we have x-axis symmetry. And then for y-axis, we're going to let x become negative x. And you can probably see that same type of thing is going to happen. We get the original, so we do have y-axis symmetry. And then for origin, we're going to change them both. And if we change them both, I think we see what happens. So we have symmetry for all three, x, y axis, and the origin. All right, so for 15, we'll start looking for intercepts for number 15. And so for x-intercepts, we're going to let y be 0 and solve. And we'll multiply both sides of this by 2x to the 5th, and that gives us 0 equals x to the 4th plus 1. We subtract 1 from both sides, and we get negative 1 equals x to the 4th, and now we're going to do the 4th root of both sides, and the 4th root of a negative number is not real. So that tells us we do not have an x-intercept. If we solve and we don't get a real number result, then that can't be an x-intercept. All right, now let's test for y-intercepts. So we're going to let x be 0, and you can probably tell right off the bat that we're going to have 0 plus 1 over 2 times 0, and division by 0 is not possible, so we don't have any y-intercepts either. All right, now let's do our symmetry test, and we'll test for x-axis symmetry first. So I'm going to let the y be negative y. Observe that this is not going to give us the original equation back if we replace y with negative y, so we do not have x-axis symmetry. Okay, and if I replace, testing for y-axis symmetry, I'm going to replace x with negative x and see if we get the original equation back. The top is the same, but the bottom will not be because it will be negative. So we do not have any y-axis symmetry. However, testing for origin symmetry, where we change both x and y, we will have negative on the left, and this right side is going to become negative as well. So I'll just come over here. Since this denominator is going to become negative, that in essence makes this entire fraction become negative. And if we were to divide by or multiply by negative 1 on both sides, we would get the original fraction. So it is possible, when you let both of the variables become negative, you can get the original equation back. So we do have origin symmetry. All right, and for number 16, we're supposed to write a linear equation that represents this scenario, and we're told this guy makes a salary, and so salary is determined by he gets 5% of profit on sales that he generates, and we're told that that's what X represents when he has sales that generate a profit called X. So he gets 5% of that number. And then he gets this flat rate in the sales world that's called a draw, just to kind of help salespeople out if they happen to have a particular bad period, week, or month. They can count on this to get them through until they get their sales back up again. So that would be the equation, the linear equation that represents this scenario given to us in number 16. All right, number 17 is a circle equation, but this is called general form, and we need to get it in standard form so we can find the center or the radius and sketch the graph. So I'm going to put the x variables together side by side. Same thing for the y's. I'm going to move the constant over to the right by subtracting, and now we're going to be completing the square on both x and y. All right, I just divided these linear, the x and the y, by 2 in both cases. And now we got to balance out the equation. I have created plus 1/4 by doing x minus 1/2 quantity squared, so add a fourth to the right. And I've created plus 1 squared, by doing this, completing the square. So when you simplify all of that on the right side, it just ends up being 1/4. So we can see now that the center is the point 1/2 -1. The radius, remember in standard form, this is radius squared, so we've got to do the square root of this to actually get the radius, and that would be 1/2. And now let's graph the circle. It's going to be a really small circle. 1/2 -1 is the center. And then we have a radius of 1/2 all the way around. So just a little tiny circle. And it is important, I think, we got to find intercepts if there are any, and I do think don't rely on your graph because it could be wrong. So this is a good way to check, and I'm going to ask you to show this on your test to prove algebraically where the intercepts are. So if I want to find x-intercepts, I'll let y be 0 in this standard form. And if y is 0, that's 1 squared, which is 1. And I'm going to subtract 4/4 from both sides, and that gives me -3/4. And now I'm going to be doing the square root of both sides. Well, I will end up doing the square root of a negative number, which is not real. So if you're trying to find intercepts and you end up with I as a result, then that tells you that you do not have any of that particular intercept. So in this case, there are no x-intercepts. Okay, let's see about y-intercepts. So I'm going to let x be 0. So if x is 0, that's -1/2 squared, that's 1/4. Now I'll subtract 1/4 from both sides. I'll do the square root of both sides, and the square root of 0 is still 0. And then subtracting 1, that confirms what I came up with on the graph. I should have a y-intercept at -1, or you could say, if you use ordered pairs, you could say it's at 0, -1, either way. So there's the complete answer for number 17. Number 18, the endpoints of the diameter of a circle are given. And so we need to find the center, which will be the midpoint between these 2 points. And so what I'm about to show you is, this is called the midpoint formula, where you add the 2 x coordinates for the 2 ordered pairs and divide by 2. And then you add the 2 y coordinates and divide by 2. And doing the simplification here, this is 2 divided by 2, which is 1. And this would be -4 divided by 2, which is -2. So that's the center. And so that's done. And now we find the radius. And so the radius is the distance from the center to either one of these endpoints of the diameter. Doesn't matter which you pick. I'm going to do the distance formula. And I'll just go with this point. So the distance from the center to this point will be the radius. So the distance formula is the difference between the x's squared added to the difference between the y's squared. And this is going to be 4 squared, which is 16. And this is negative 4 squared, which is also 16. So the radius is the square root of 32, or I think your answer sheet shows it as 4 root 2. So there's the radius, and the standard form equation now would be x minus 1 quantity squared plus y plus 2 quantity squared equals, now remember this is radius, either one of these is the radius, and so the equation calls for radius squared, so we need to raise this to the second power and we'll get regular 32. So there's the standard form equation to go along with center and radius, and there's your final answer. All right, we'll finish this up with a couple of word problems involving variation. And this first, number 19, is an example of inverse variation. So inverse variation is going to involve division of some number into k. K stands for the constant of variation. So weight varies inversely with the square of distance. So k will be in the numerator always for these inverse variation problems. And then in this case, it's going to be divided by distance squared. And now they're going to give us some information to help us identify the exact number to use for k, so we can finish up by answering the question. So a body weighs 55 pounds, so W is 55. And when it is 3,960 miles from the center of the Earth, so we're going to let these numbers help us identify what to use for k, and then we'll be able to answer the weight question. So go to your calculator, and we're just going to do 55 times 3,960 squared, and that is 862,488. All right, so I'm just going to go ahead, I just wanted you to see where we got that number, and I'm going to go ahead and replace our original k with that. So this is the equation that will help us find either weight or distance, whichever, and in this case, we're trying to find weight given distance. Okay, so weight is that same number, 862,488,000. But to find out the weight when it is 3,965 miles, we're just going to replace D with that number to get our final answer. All right, so we already have the 862 million number in our calculator, so let's just divide that by 3,965 squared. And to the nearest hundredth, that's 54.86 pounds. And that's the answer for number 19. Number 20 is an example of joint variation, and that will always mean all multiplication, multiplying k by multiple quantities, and for you that's going to be 2. So let's interpret this first sentence. The force exerted by the wind on a plane surface varies jointly. All right, so k is going to be multiplied by the area and the square of the velocity. And so once again, let's see what we're told to help us find out what this important constant of variation is called K. All right, if the force on an area of 20 square feet is 11 pounds, so force is 11 when area is 20 pounds, and when the wind velocity is 22 miles per hour, so V is 22, and then we have to remember to square it. So let's go to our calculator, and we're going to do 11 divided by 20 times 22 squared. And you're looking at your calculator, and just so you can make sure you match up, 0.0011363636. Okay, so that's going to be K in this original. And I'm just going to show you that goes where K was, but I'm not going to round it yet. I'm going to save the rounding for the last, and so we can get a as exact as possible answer. Okay, so now that we know what our equation looks like, we can answer this question. Let's find the force. Okay, so force is going to be found by taking our K value, multiplying by 47.125, that's the area. Okay, I'll just erase this and give myself a little bit more room. 47.125, and the velocity is 36.5 squared. So all of that, all these three together, multiplied together, will be our answer for the force, and that will be a number in pounds. So that decimal is still there in my calculator, so I'm just going to say times 47.125 times 36.5 squared, and to the nearest hundredth, that's 71.34 pounds. And that should do it. And so that completes our semester exam review of chapters 1 and 2, and chapter 3 will be next. I hope this helps you as you prepare for the semester exam. If you have any other questions, let me know.